Okay, so, all right, so I'm going to take and do what next now? No, I'm going to add this column up, right? Because this is a sum of all, this should be the sum of all the data points. If I add that column up, sum of all the data, and those that have it done, if you would check your work with me, that'd be great. 65 plus 105, 250, 315, 495. How about 1230? Okay, this is 1230. Now, I know the mean, right, is simply the sum of all those data points divided by how many there are, right? There's 50 data points. So the mean, is this a sample? This is a sample, so I use x with a bar. It's 1230 divided by 50, and that is 24.6. So, now the standard deviation, I got to do some more work here, because I got to find the difference between the midpoint minus the mean. Right? So, this one is 5 minus 24.6. And it's negative 19.6. This one would be 15 minus 24.6. Negative 9.6. This would be 25 minus 24.6. That's 0.4. This is 35 minus 24.6, and that's 10.4. And this one is 45 minus 24.6, and that would be 20.4. What's my next step?
Take that squared. Times the frequency.
I have to square that number, right?
Yeah.
It's the midpoint minus that squared. But the difference between group data is I have 13 of these, right? So I got to take it times 13. I could add it up 13 times because there's 50 of them to add up. But again, in grade school, you learn that it's easier to do multiplication than the repeated addition. So this will be 19.6 squared times 13, and I got that to be 4994.08. That's right.
Well, I just said 39.
So 9.6 squared times 7. 645.12. 0.4 squared times 10. 1.6. 10.4 squared times 9. 973.44. And 20.4 squared times 11 is 4577.76. I need to take and find the sum of that, right? Add those numbers up. So 4994.08, 645.12, 1.6, 973.44, 4577.76, and I get a total of 11,192. That look right?
Yeah.
Now, find the variance, right? Now, this is a sample. So the sample, S squared, which is the variance, right? This is variance. So variance is equal to, our formula was the summation of the midpoint minus the frequency squared times the frequency, midpoint minus the mean squared, divided by its n minus 1 because the sample data. So the variance is, let's see, 11,192 divided by n, which is 50, minus 1 would be 49. And I got 228.41. Now what's the book say it should be? 228.41, yes.
So how do we know that when it's divided by n or is minus 1?
Right, because if it says it's a sample or population, they have to tell you what type of data it is. If you were not told, you would not know. So this says that the following approximate the sample variance. So again, that's a key word, that this is a sample. And that's why I'm using this symbol here for a sample. So important now is to make that distinction between sample and population. Now, obviously, to find this standard deviation S, which is a standard deviation, it's the square root of 228.41. The square root of that number. Square root of the answer, 15.11.
Hey, they're back.
That was very fast. Well, I'll tell you what I